Hello students, in this video we are going to learn how we can create a circuit diagram. What is circuit diagram? Circuit diagram is graphical representation of a Boolean circuit. That is, the circuit which is present in the IC, we represent it in the form of Boolean function, that is logical function, like this. This is a logical function, or we can say this is a Boolean function, and we have to draw the circuit diagram of this function. So circuit diagram is what? It is a graphical representation of this function. Now how we can do this? So to draw the circuit diagram, as I have told you, circuit diagram is graphical representation of a Boolean function, graphical representation, pictorial representation of a logical function. It helps in industrial design of the IC. So today's task is to draw a circuit diagram. A circuit diagram can be drawn with the help of logic gates. There are three types of logic gates: basic gate, universal gate, and a special gate. In this video we will learn only the basic gate. Other gates we will learn in the next coming video. Basic gates. Gates are what? Gates are the transistors which helps in the development of integrated circuit. There are three basic operators, that is not, and, or. So on the basis of that, there are three basic gates, not, and, or. The representation of NOT gate is this. It is a unary operator. It is a unary gate which consists of one input and one output. Suppose the input is X, then the output will be X naught. This is what? This is NOT gate. This is a representation of the NOT gate. Remember that in Boolean algebra, the flow of input always from left to right direction. If you make the gate like this and you put the arrow like this, X and X naught, then that will be wrong. In Boolean algebra, it is a convention that input occurs from left hand side, output comes from right hand side. So always you have to draw the circuit diagram from left to right. This is first NOT gate. Second AND operator is here. So I am drawing the AND gate. It is a binary operator. That's why AND gate contain two or more input. Let us say two inputs X and Y are there, and the output is XY. It is AND gate. Third one is OR operator, OR gate. Again it is a binary. It consists of two or more input, and this is the output X plus Y. This is OR gate. These are three basic gates: NOT gate, AND gate, OR gate. Draw these gates in your notebook so that while creating the circuit diagram you need not to refer it again and again. Again, NOT gate is a unary gate which consists of one input and one output. Suppose input is X, then we represent the output as X naught. Binary gates, AND and OR, these are two binary gates which consist of two or more input. Suppose three inputs could be there, x, y, z, or more input could be there. It consists of two or more input and one output, or it consists of two or more input and one output, and is represented by multiplication or is by addition. Now let us draw the circuit diagram of the following function. The task is draw the circuit diagram of the following function. Now how we can draw the circuit diagram is that first, after seeing the expression, just identify how many inputs are there. In this question there are three inputs, that is x, y, z. X, y, x, z means three inputs are there. So first draw these three lines. X, Y, Z. These are three input lines. Okay, I am telling you the best and effective method to draw the circuit diagram. So these are three input lines, that is x, y, z. Now the thing is that how much long we should create the text file, these straight lines. Remember that one term generally occupies three lines. So how many terms are there? 1, 2, 3, 4. So in this expression 4 terms are there. So 4 into 3, 12. So for roughly idea, I have drawn this line to cross these 12 lines. So in this way you can simply draw these lines. Let us take a rough idea. Means to draw one term, three lines are required. Now there are 4 terms, so we have draw this straight line to cross these 12 lines. It is a rough idea. If we want to extend it, then after that we can extend it. Now remember that I am telling the method to draw the circuit diagram. First you need to draw the terms of the function. Don't see how they are joined, means here it is plus into plus, don't see it. First simply see the term, means this one, this term, second term, this one, third term, fourth term. First you need to draw the terms of the Boolean function. Now let us draw the term x naught, y, z naught. X naught means we have connected with the x, and after that we have used the NOT gate. Now this is the x naught. Another term is y, which is connected with y. Another term is z naught. So another term is z naught. So we have connected it with z naught. Means x, y, and z. This is z naught. All the three terms are multiplied. To multiply these, we have to use AND operator. So this is the first term. Now the second term, x, y whole naught. X we have connected with x, then we have connected with y, and we have multiplied it. So for multiplication we have used AND, and after that it is a whole naught. So after that it is whole naught. This is second term. Third term is x plus y, x and z, x plus z, x and z. We have to plus it. For plus we have to use OR operator. This is third term, x plus z, x, z, or then the last one is z naught, z not. So first we have drawn all the terms of the function. Now we have to join the term. The highest precedence of the operator is not, after that and, after that or. So this is the precedence of the operator. So according to the precedence, first we need to join these two terms because they are connected with AND operator. So we are joining these two terms. Now this one is ready. We have joined these two terms, that is xy whole not, xy whole not, and x plus z, x plus z. We have combined these two terms. And after that, now look at this. One middle term and third one, these are added. So plus is here, plus is here. Look at this. Now you have to combine all the three terms together. Don't do like this, add first two then no, you have to draw the circuit diagram by using minimum number of gates. So the terms which are combined with common operator, that has to be joined with the same operator in the same gate. So you look at this first term, this is now the one term, and this one, last three terms. These three terms are joined with this plus operator. Look at here. So we have joined this term, this one, and this one. Means this is the first term, x naught y z naught. This is the second term, this one, z naught. This is last term. These are combined with OR operator. So I am using OR operator here. So this is the circuit diagram of this function. So how we have drawn the circuit diagram of this function? First you need to draw the term 1 2 3 4, 1 2 3 4, 4 terms are there. After that you have to join the term. First you need to join the terms which are get multiplied. So here these two terms get multiplied, here these two terms gets multiplied, so we have joined them. After that we have added all the term 1 2 3. So to add all the term we have used OR operator. Now you have to write the expression of this logical function, of this logical circuit. Now how we can write the expression of this logic circuit diagram? Now let us see. This is x naught, this is y, this is z naught. These three are multiplied over here, so it is x naught, y, z naught. This is what? This is x, this is y, get multiplied and after whole naught. So this is xy whole naught. This is what? X and z get plused, x plus z. This is what? Z naught. Now here these two terms get multiplied. So what you will get here? Here you will get xy whole naught multiply y x plus z. So this is the output at this point. Now here 1 2 and 3, these are added, so here the output will be x naught y z naught plus second term x naught y x plus z plus third term z naught. So this is the final expression over here. So you are getting the same expression which you have drawn for this circuit diagram. So in this way you can draw the circuit diagram. So remember that to draw the circuit diagram there are three types of gates: basic gate, universal gate and special gates. In basic gates three gates are there, that is NOT, AND, OR. NOT is a unary gate which consists of one input and one output. AND is the binary gate which consists of two or more input and one output. OR is the binary gate which consists of two or more input and one output. This is a representation. Now in this circuit diagram, first I have told you just identify how many variables are there, how many inputs are there. Suppose there are three inputs, then you have to draw these three lines. Suppose there are four inputs, x, y, w, x, y, z. So w, x, y, z you have to draw four lines. After drawing the input lines, just draw the terms which are given in the question. So in this question four terms are there. We have drawn these four terms. After that, join the term. You can join those the terms which are joined with AND operator first. So here two terms are joined. So here two terms are joined with AND operator. Thus we have used AND operator over here. After that we have joined all the terms together here. Remember that you have to draw the circuit diagram by using minimum number of gates. Means don't do like this. First you add this, then multiply this, then add this. So that will be wrong. Thank you.